It was supposed to be routine. Another night of deep sky imaging, another comet caught gliding through the solar glare. But what astronomers saw on November 10th, 2025, was not routine. The new images of 3 Atlas, our third recorded interstellar visitor, arrived in a quiet data stream that few noticed at first. Yet those faint pixels told a story that has since rippled across the entire scientific world. Because in those images, there was something missing. No plume of gas, no glowing trail of dust stretching into the darkness, no luminous arc curling away from the sun like a banner of vaporized ice. Just a single self-contained point of light, unmoving, unbending, unbroken, a comet with no tail, a traveler that defied the physics of sunlight itself. For months, scientists had predicted that as Atlas swung around the sun, it would erupt in brilliance. Its icy crust would boil, its surface would fracture, its body would release torrents of gas as gravity and heat stripped it bare. That's what nature does. That's what the models demanded. But the universe had other plans. The brightness changed, yes, but the structure remained the same, a smooth, symmetrical core burning blue in defiance of every known law. To some, it was simply an anomaly. To others, it was something far greater. The first smoking gun for an extraterrestrial artifact hiding in plain sight. The first hint of impossibility came not from the images, but from the numbers. Observatories tracking 3I Atlas's orbit noticed a subtle deviation, a drift that couldn't be explained by gravity alone. The data from NASA's Jet Propulsion Laboratory revealed something astonishing: non-gravitational acceleration. It was as if the object were being pushed by an invisible force. In comets, this is common. Jets of vapor erupting from sunlit ice act like miniature thrusters, nudging the nucleus slightly off course. But what Atlas did broke that pattern entirely. The acceleration wasn't random or chaotic. It was precise. Instead of a messy wobble caused by uneven gas release, its motion followed a smooth curve, as if under the guidance of control. JPL's report listed an outward acceleration of 1.1 times 10 astronomical units per day squared, and a sideways drift of 3.7 times 10 astronomical units per day squared, numbers that implied a thrust large enough to alter its path without destabilizing it. To achieve that naturally, Atlas would have had to eject almost 13% of its total mass in gas and dust. That's billions of tons, enough to create a tail visible even from small amateur telescopes. And yet, the sky was empty. No dust, no vapor, no visible sign of escape. It was as if something inside the object had shifted energy, not mass, as though it had maneuvered rather than erupted. The calculations refused to align with any known model of cometary behavior. The equations worked, but nature didn't. That's when scientists began whispering what none dared to say out loud. What if this wasn't a comet at all? To verify the anomaly, astronomers turned to comparison. They chose Comet Lemon, a similar body observed under the same solar conditions just 2 days earlier. Lemon looked exactly as expected, a graceful arc of vapor streaming behind it, sculpted by sunlight into a luminous blade. But when the same instruments captured 3 Atlas, the difference was immediate and shocking. The tail was gone, not faint, not incomplete, gone. Atlas appeared as a single luminous dot identical to its appearance months earlier before perihelion. No debris field, no scattering halo, no extension of light in any direction. Even after enhancing contrast and filtering background noise, the tail simply didn't exist. It's like the sun forgot how to touch it, one astronomer commented. At first, some blamed equipment error. Perhaps the coronagraph failed to catch faint emissions, but multiple observatories using different instruments across continents confirmed the same thing. Atlas remained stubbornly compact. That compactness, paradoxically, was what made it so unsettling. Every cometary outburst ever recorded in our solar system leaves a signature, a fingerprint of chaos that lingers for weeks. But this explosion had no fingerprints, no residue, no wound. It was as if the energy that left the surface had re-entered it, as if the object had exhaled light without losing substance. The data began to feel less like an observation and more like a message. When NASA released its photometric analysis, the contradictions deepened. The models that normally describe comet outgassing failed spectacularly. The object wasn't shedding enough material to cause its observed acceleration. It wasn't heating as fast as it should under solar radiation. It wasn't cooling afterward either. Its temperature profile, derived from spectral readings, remained eerily stable, a thermal consistency that no natural body this size should maintain. Then came the composition puzzle. Spectroscopy revealed strong nickel signatures but almost no iron, a ratio that's virtually impossible in cosmic geology. On Earth, that ratio appears only in industrial alloys, metals forged to resist corrosion. The implications were staggering. Theoretical models tried to replicate the observed data by invoking exotic ices or hydrogen release, but the results never matched reality. Hydrogen would leave emission lines. Exotic ices would fragment unevenly. Atlas did neither. It behaved like a system managing its own temperature, a mechanism balancing inputs and outputs with precision. In other words, it behaved like a machine. But the idea that this object could be technological, a probe, a messenger, something built, was too much for the community to accept publicly. For now, they called it an extreme outlier. Yet privately, many admitted, there's no physics here we can recognize. At Harvard, Dr. Avi Loeb was among the first to notice that 3 Atlas wasn't just an anomaly. It was a pattern repeating itself. Years earlier, Oumuamua had displayed the same signature: acceleration without outgassing, reflectivity inconsistent with rock, and motion that hinted at control. Now Atlas was doing it again, but even more blatantly. In interviews, Loeb's voice carried a mix of curiosity and exhaustion, the sound of a scientist who has asked one question too many times. When data repeats, he said, you're no longer studying coincidence. You're studying behavior. He urged NASA to release the unreleased Mars orbiter footage that allegedly captured Atlas during its perihelion phase, arguing that transparency was essential. The public paid for these observations, he said. They deserve to see what the universe is showing us. His request sparked quiet unrest within the scientific community. Some admired his courage, others called him reckless, but even his critics couldn't dismiss the truth. If Webb and Hubble confirmed that Atlas emits no detectable gas or heat, then every natural explanation collapses. The line between science and speculation would blur. And for the first time, alien origin would move from conspiracy to hypothesis. In a collaboration that startled even skeptics, data analysts and astrophysicists applied Bayesian probability models to quantify how unlikely Atlas's behavior really was. The final figure was almost absurd: 40 trillion to 1 against a purely natural explanation. Each anomaly contributed to the odds: the non-gravitational acceleration, the absence of a tail, the perfect ecliptic alignment, the metallic composition, the negative polarization, the sunward jet, the retrograde orbit, and now the precise timing of its perihelion explosion. Each factor alone could be dismissed, but together they formed a statistical monument to improbability. "We've run out of coincidences," said one researcher privately. The probability threshold wasn't just crossed, it was obliterated. The model didn't prove intention, but it demanded it. Statistically speaking, a comet doing what 3I Atlas has done is as likely as a coin landing on its edge 10 billion times in a row. When the numbers themselves refuse to play by chance, belief becomes the final refuge of ignorance. Loeb's response was simple: The data doesn't lie, our interpretation does. As more telescopes trained their eyes on Atlas, a chilling hypothesis began to circulate among those willing to whisper it. Perhaps the absence of a tail isn't a mystery at all. It's a feature. In engineering terms, propulsion without exhaust isn't impossible, it's advanced. Theoretical designs for light sails, ion drives, and magnetic accelerators already exist in our own laboratories. They produce thrust silently, invisibly, leaving no plume of dust or heat. If an advanced civilization wanted to explore the galaxy discreetly, this would be the perfect method. Design a vessel to mimic natural debris. Give it a surface that scatters light like dust and let it drift, appearing random to everyone except those who look too closely. 3 Atlas could be exactly that, a disguised probe operating under laws of thermodynamics we barely understand. Its perfect symmetry and reflective control hint at intention. Its lack of chaos implies design. Its acceleration without decay suggests internal management, not external reaction. In other words, this might not be the wreckage of another world. It might be its messenger. Science lives on skepticism, but sometimes skepticism becomes a cage. Many astronomers refuse to engage with the artificial origin theory, calling it speculative nonsense, a distraction, even a career risk. Yet as the data mounted, silence became harder to defend. When every natural hypothesis fails, denial turns into dogma. The history of science is littered with such moments. Galileo's telescope, Darwin's fossils, Einstein's equations, all met with ridicule before acceptance. Now perhaps it's happening again. Loeb's insistence that we consider non-natural explanations isn't fantasy, it's method. As it moves beyond Jupiter's orbit and disappears into the outer dark, 3 Atlas leaves us with a choice. We can turn away, label it an anomaly, and protect our comfort. Or we can face the possibility that we just witnessed proof of intelligence far older than our species, one that might have been crossing the galaxy long before our planet cooled. Either way, this moment will echo. It will be written in textbooks, whispered in laboratories, and replayed in the minds of everyone who dares to look up and wonder what else is out there. Because maybe, after all this time, the message wasn't hidden in a signal or a sound or a transmission. Maybe it was in the silence, a silence so perfect it demands to be heard, a silence that says, we were here, we are watching, and we still are. If this story made you question what you thought you knew about the universe, don't let it fade like the light of 3 Atlas. Subscribe to this channel because we'll keep following what the world's telescopes find next. Turn on notifications because the next object could already be on its way, and this time, you won't want to miss it. And tell us in the comments, what do you think 3 Atlas really is? A comet, a probe, or the oldest message ever sent through the stars?